There's two different ways that you can set up this buffer. Linear just goes from beginning to end, and once the end is reached, in this case once we get our 512 kilobytes, that's it. It's going to be full and you're not going to be able to add any more information to that. Whereas circular is analogous to like the logging buffer on your router, whereas once it hits a certain point, once it fills up this 512 kilobytes of information, it's going to start over at the beginning and start rewriting this. So it's always going to be filled up. So you're going to always have the most recent packets that met your criteria. A lot of the work with getting a packet capture is done long before you actually do the analysis. It's setting it up and getting the right type of packets. You're going to want to think this out when you're doing it rather than just jump in there and start tweaking. And here's some of the options for the capture buffer. And there's a lot of good options in here. We kind of went over circular versus linear, the difference between those. By default, you're going to be using linear. Clear is just to clear it. You can have filter access lists. You do have some cool options here where you can allow every nth packet, instead of capturing every packet that meets your criteria. Say you just want to sample and grab every 100th. You can do that. That's going to keep down the size of your buffer. You can have a duration. So this is kind of cool. You can say, I only want this buffer to be available for, the next 20 seconds, and you can crank that up to some ungodly number. You can specify the number of packets that you want. Say that I only want 100 packets. You can do that as well. You can set it to packets per second. Like I said, there's quite a few options here. So take a look at these before you do your packet capture and see which ones you want to utilize. The size of the buffer ranges from 256 kilobytes to 100 megabytes. I would check this on your particular device because I think this does vary by platform. So now that we have a buffer to put our capture in, we have to say, where are we going to capture this? And that's what a capture point is. So capture point, I'm going to use monitor capture, and then instead of using buffer, we're going to use the keyword point. And then you'll be able to choose IPv4, IPv6, Ceph versus process switching. Then you're going to give it a name. I used internal LAN. That's kind of hard to read. And then specify an interface. And you actually have an option for all here, which just seems like a really, really bad idea. And then you'll decide which direction. Do you want to go ingress, egress, or both directions? In this case, we're saying, let's go ahead and capture everything on fast Ethernet 0/1 coming and going. When you do this, iOS is going to say, hey, you created this capture point. Now that you have both of these pieces, you have a capture point and then a capture buffer, you need to associate those. And you go and do that with the capture point as well. You associate a point with a buffer. I would use the iOS help here just so you get the order right. You're going to specify the point first and then the buffer. So in this case, we're going to say, let's associate my capture point internal LAN with this buffer called my capture buffer. And here's some of the capture point options. There's not quite as many as the buffer, so you actually do most of your filtering of your packet capture on the buffer rather than on the capture point. You can decide IPv4, IPv6, Ceph versus process switch, in, out, both. And then from us is actually kind of interesting. It specifies packets that are originating locally. And that might bear more investigation. I didn't look at this too closely. Don't remember seeing this on the command line, but this would be very useful for packets that originate from your router like BGP or OSPF. You might want to look into that. So now that we've created a capture buffer and a capture point and we've associated them, we're golden. We can start our packet capture. And once again, this is under the monitor capture point, and you can start and stop from there. You can start all capture points if you would like. We could have done that in this situation because we only have one specified, but if you have multiple, you're going to want to specify the capture point. And you can see here it's been enabled, which means we are actually starting to capture packets at this point. And then once you've captured enough packets, you can go ahead and stop, and you do it the same way. It's just using monitor capture point stop rather than start. So you have two options at this point. You can take a look at the packets on the router with the dump command. We'll take a look at that in just a bit. Like I said, most of the time you're going to want to move this packet capture to another device that has more robust packet analyzing software installed. Wireshark is my favorite for doing this. And you have a number of options to do this. You can use FTP, HTTP, secure HTTP. TFTP is what we're going to use in this example. Don't know what PRAM is. The way that you're going to do this is to use the monitor capture buffer command, which makes sense because you're moving the information from the buffer. You'll have to specify the buffer and then export and go ahead and specify a location. One thing to keep in mind here is if you're used to Cisco IOS, you can usually specify a location for TFTP. Hit enter and it will generally prompt you for some additional information, the name of the file. It won't here, so you're going to want to specify a file. You do not have to specify the extension, the .pcap. I did that so I didn't have to rename it later on my server. If you don't specify this name, you'll get this error, export of capture buffer failed. And then you can see there's not a lot of detail to this, so you're not sure what's going on. You might be thinking, oh, is TFTP not running, blah, 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 blah. Just specify the name and you'll be good. So then once you get this moved to a device that has packet analysis software on it, go ahead and fire it up and take a look at the packets. So once you're done, you might want to clear the packet capture buffer. We'll take a look at the verification commands in a little bit here, but one of those is show monitor capture buffer. Then you can have the name and then the parameters. And you can see here that this packet capture was 36 packets. So then to clear it, just go ahead and monitor capture buffer, name it, and then clear. And when you take a look at this again, you will see that there are 0 packets in there. And then to disassociate a capture point from a capture buffer, you might be doing this if you're just tearing out all the configuration that or if you want to associate this capture point with a different capture buffer. You can only associate a capture point with a single capture buffer. The command for that is basically just the opposite of associating it. It's monitor capture point rather than associate. We're going to say disassociate and then the name of the capture point. And since it's only associated with one buffer, you don't have to specify the buffer. It'll know which one it is. So another one of the verification commands that we're going to get to in just a bit here is the show monitor capture point all. And you can see here that this one is not associated with a capture buffer. And you can go ahead and do the same thing on the buffer itself and see which capture points are associated with it. Remember that you can have multiple points associated with a single buffer. You're just looking to see to make sure that your capture point is no longer associated. And then to delete capture packet buffers. And then to delete packet capture buffers and capture points, you're just going to use a no version of the command. So no monitor capture buffer, and then specify the buffer. So then when you do a show the capture buffers, it will say that it does not exist. Same thing with the capture point. This is what Cisco referred to as destroying a capture point. And then when you do your verification command, you can see that it no longer exists. And like I said, it's highly recommended that you export the packet capture to another device and use something like Wireshark to analyze the packet capture. But you can do this on the router, and you do that with the dump command. You specify your capture buffer and then dump. You can see here it gives you some real basic stuff here. I don't know how much use you'll get out of this. Like I said, strongly recommend the exporting of the packet capture and using something like Wireshark. But you do get the packet metadata as well as some of the information here. You can see somebody was going out to Facebook. And the dump feature does give you some filtering ability so that you don't have to look at everything. If you've got 1,000 packets, you're not going to want to just sit there and go through each of them on the screen. You can use some filtering here. You can filter on direction, input interface, the layer 3 protocol, output interface, packet size, and then time. I'm not going to go into these in detail. You can play with these if you like, but it does give you some ability to filter when you're looking at the output on the router itself. Okay, and verification commands, and we did take a look at these guys just a little bit earlier. There's 2 very good verification commands associated with EPC, and that's basically looking at the buffer and the capture point. So you can see show monitor capture buffer. If you invoke the question mark for the iOS help, you can specify this by the specific buffer by specifying the name. You can look at all of the buffers merged. You know what? I don't know what that is because I didn't play with that. I only had a single buffer on here. Once you get to the end of this, it's kind of weird because you think you should hit all or the specific one and hit enter, but you have to type out parameters. Even though that's the only option, you would think that Cisco would just be like, okay, all is sufficient. Anywho, so you take a look at this. It's got some really good information. It shows you the buffer name. It shows you if it's linear or circular, gives you the size of the buffer. This first value is the size of the buffer. And then the maximum element size. This is the maximum size of the capture per packet. So you're only capturing the first 256 bytes, and the number of packets that are stored in the buffer. So this is good verification to see if you captured anything, because you could set up a packet capture and nothing meets your criteria, or you screwed something up. If this says packet 0, then you know that nothing has been captured. When you get into more advanced options, it shows that there too. The allow nth packet, the duration, maximum packets per second. Here's where you can see which capture points are associated with that buffer. And remember, with a buffer you can have multiple capture points associated. In this case we only have one. And this little bit right here is really cool too, because this will tell you if it's actively capturing packets or not. If you think that you stopped your packet capture and you see this is active, then you need to go ahead and make sure that you stop that packet capture, especially if you got this set up as a circular buffer, because it's going to keep capturing those packets. Both of these commands show the configuration. I really like this. This is very cool. It shows you what has been configured here, and this is really useful, especially when you're trying to destroy or delete these buffers and capture points.